Good morning, learners. My name is Mr. Pochilola once again, your teacher here on Black Slides online platform. We meet on this forum for lessons in physics, chemistry, biology, and mathematics. So feel free to learn from this channel and keep in touch, making sure that you visit the channel frequently for newly uploaded videos or lessons. But also remember to like and subscribe to the channel so that you don't miss any lessons that are uploaded. So once again, welcome to this lesson number 1 of a Form 4 topic called the thermal expansion. So we meet here for the first lesson on a topic called the thermal expansion, which is a Form 4 topic for your Msce physics. This topic comes first in Form 4. So we meet here this time for the first lesson on the topic called the thermal expansion. Let me urge you to keep watching, to watch the video up to the end. And I would also advise that you should have your notebook and a pencil to scribble short notes, noting down the key points. And as we explain the key ideas relating to the topic, your examiners will actually be interested in examining you on your understanding of the key concepts, the key ideas, which are key to physics. Right, so for each key concept that we mention and that we discuss, as well as define, make sure you note it down and convince yourself that you fully understand. If you're not, you can rewind and watch the portion that has that particular key concept until you are sure that you understood. That's very important. But in case you miss a point and the lesson does not address your doubts, feel free to contact me for clarification. So once again, welcome to the topic called the thermal expansion, which is our first topic in Form 4 physics. All right, so in this topic, when you complete the topic and you finish learning the topic, it is expected that you should be able to carry out the following tasks. So by the end of the topic, you should be able to define the term temperature. What is temperature? What do we mean by temperature in physics? So we are going to define the term temperature, and you should be able to do the same when you have fully learned the topic. You should be able to explain the thermal expansion of solids, liquids, and gases. Remember, solids, liquids, and gases are known as the states of matter. The 3 states of matter. So these are 3 states of matter: solids, liquids, and gases. All right, so we are going to explain their thermal expansion. Thermal expansion of solids, liquids, and gases. But also it is expected that you should be able to explain expansion in terms of particle behavior. in terms of particle behavior. Sometimes we say molecular behavior. So particle behavior, sometimes we say molecular behavior. So in terms of the behavior of molecules, particles, how do we explain expansion? In other words, we are looking at what happens to particles as a substance or an object is being heated. How do particles behave or molecules behave in a substance that is being heated? All right, so we explain expansion in terms of the behavior of molecules. All right, and also it is expected that after you have completed the topic, you should be able to describe the anomalous or unusual behavior of water. You may have learned in Form 2 that when water is cooled below 4 degrees Celsius, instead of contracting like other substances, it expands. All right, so we are going to describe that behavior in this topic, and also it is anticipated that you should be able to do the same to describe this anomalous behavior of water when you finish learning the topic. Last but not least, we are going to look at the effects and applications of thermal expansion. So we are saying you are going to define the term temperature, explain thermal expansion of solids, liquids, and gases, explain expansion in terms of particle behavior, and describe the anomalous expansion of water and its effects. And lastly, you should be able to explain the effects and applications of thermal expansion. So these are the success criteria of the topic thermal expansion, which is the first topic in your Form 4 class. So once again, welcome. All right, so let us look at some definitions that are key to the understanding of this topic. All right, the first one is temperature. Let us define the term temperature. What is temperature? In Form 1 as well as in Form 2, you define the temperature as the degree of coldness or hotness of a body. Remember, body is used in physics to mean any object or simply matter. All right, so temperature is the degree of coldness or hotness of matter. All right, remember that you cannot judge the hotness or the coldness of a body or an object or any substance by simply using your sense of touch. All right, in physics, you have to quantify the coldness and the hotness using an instrument called a thermometer. All right, so temperature basically measures the average kinetic energy of molecules of a substance. Remember that kinetic energy is simply the energy of particles due to their motion. All right, so when a substance is heated, such a substance is going to gain kinetic energy. So a measure of the average kinetic energy of molecules in such a substance is called the temperature. You learned in Form 3 that kinetic energy is basically given by the formula Ke equal to half the mass of the particles multiplied by the square of their speed. All right, so but basically this is supposed to be the sum. It's the total kinetic energy, in this case the average. All right, so we are looking at all particles together, so not just an individual particle. So it's more appropriate to look at or to consider the sum of the kinetic energy of all the particles, the average. Right. When the temperature is low, molecules tend to move slowly and move faster when the temperature is high. So in this case, what we are saying is that when temperature increases, remember that when the temperature of a substance is increased, the particles in it will gain kinetic energy. And the opposite is the case. When the temperature is decreased, the temperature of the molecules of the substance is decreased, the molecules also lose kinetic energy, therefore they move slowly. So we are saying when the temperature is low, molecules in that particular substance tend to move slower, but when the temperature is raised, the particles move faster. Why they move faster is because upon heating they gain kinetic energy. So that actually leads to an increase in the speed of the particles. All right. So when measured, temperature is measured in units called the Kelvin. This is basically the scientific unit. The SI unit of temperature is called the Kelvin. Right? So they ask you in an exam, state the SI unit of temperature. Just say Kelvin. So the Kelvin is the SI unit, the unit that is used in scientific work for temperature is the Kelvin. But also it can be measured in units which are called degrees Celsius. And remember that the degree Celsius is related to a Kelvin by the formula, supposing that you are asked to convert temperature, which is in degrees Celsius, into Kelvin. Remember that the temperature in a Kelvin, in kelvins, is simply equal to the temperature in a degree Celsius, and then whatever temperature in degrees Celsius, you just add a constant called 273.15. All right, so the Kelvin and the degree Celsius are related in this manner, and also it follows that to find the temperature in degrees Celsius, you simply subtract the temperature in kelvins, subtract the same constant of 273.15. All right. But in scientific work, it is appropriate to present temperature in kelvins rather than in degrees Celsius, unless the question has clearly instructed you to leave your answer in degrees Celsius. That's fine. All right, so in practical work, mostly in your physics lab, you measure temperature in degrees Celsius. But where needed, it is more appropriate to present your temperature in kelvins because that's the scientific unit. I hope we are together there. So we are saying that the temperature is a measure of coldness or hotness of a body. And basically, temperature measures the average kinetic energy, which is the energy of motion of the particles or the molecules in the substance being heated. All right. And the particles tend to move slower when cooled and faster when heated. So this directly relates to kinetic energy there. All right. Unless you are not certain about this one, what we have just discussed about temperature, so you should be able to define temperature in this manner. Okay. Next, let's look at the differences between heat and temperature. All right. These two terms are usually misunderstood and misplaced by some learners and some users of the terms heat and temperature. Heat and temperature do not necessarily mean the same thing, although they are related. So there cannot be temperature without heat. All right, but there can be heat. So where there is heat, there is temperature there. Okay, so in this case, temperature depends on heat. Heat must be available for temperature to exist, and not the other way around. Okay, all right, so let's look at the differences between these two concepts. Familiar, they sound familiar, but there is a difference. There are differences between the two. All right, so we can use definitions. One way to distinguish the two is to use their definitions. Okay, so you have defined in Form 3 work, as well as in Form 2 and Form 1, you have defined heat as the energy that flows from the region of high temperature to the region of low temperature. All right, so for heat to exist, there must be two regions which are at different temperatures. One region is at a higher temperature than the other. In other words, there must be a temperature gradient for heat, for this energy called heat to flow. So we are saying it is the energy that flows from the region of high temperature to the region of low temperature. So suppose we have two bodies that are in thermal contact with each other, and one body is at higher temperature than another, then heat is going to flow from the body which is at higher temperature to the region of which is at lower temperature. All right, so the energy that flows is called heat. In other words, we consider heat to be energy on the move, or simply energy on transit. All right, because it is flowing from one point to another, from the region of high temperature to the region of low temperature. So such energy is called heat. All right. On the other hand, temperature is simply the degree of coldness or hotness measured on a given scale. All right, so the given scale here can be a Kelvin scale, or a Celsius scale. Can be a Kelvin scale or a Celsius scale. All right. Usually you have thermometers that are calibrated in kelvins, as well as those that are calibrated in degrees Celsius. All right, so such a given scale can give you a degree of coldness or hotness of a substance. So in short, we are saying heat is energy that flows from one body or from one region, from the region of high temperature to the region of low temperature, and the temperature is the coldness, the degree of coldness or hotness measured on a given scale. All right. Another difference is that heat is measured in joules as its SI unit. All right, the joule. So the unit, the SI unit of energy is heat energy is the joule. Like all forms of energy, heat is also measured in joules. All right. So one difference is that in terms of their SI units, heat is measured in joules as SI unit, while temperature is measured in kelvins. We just said that as a SI unit. So in an exam, you can use the definitions of the two terms to show their differences. You get mark. You get a mark, but also you can state their SI unit. Again, you gain a mark for that. All right, another difference is that we just said there in the first difference that heat flows from one point to another. So we can use the fact that heat flows as another difference. All right, so we are saying heat flows from one region to another, while temperature does not flow from one region to another. Okay, so again, that is another difference. Let me warn you that when you are giving differences between two concepts, you can use this table method. You can use this table method. So you have two columns. You can have two columns. You have two columns in which the column headings are the two concepts to be differentiated, and then you give contradicting statements, which are basically the differences between the two. All right. Another difference is that another difference is to do with energy again. So heat energy depends on both potential energy and kinetic energy. Remember, potential energy refers to the energy due to the relative positions of the particles in that particular substance. All right, the relative position of the particles. Okay, will give potential energy. So potential energy plus kinetic energy will determine the amount of heat that is contained in a substance. So we are saying heat depends on the total potential and the kinetic energy together, but temperature only depends on the kinetic energy only. Right, so temperature depends on the kinetic energy only kinetic energy. Please take note. Heat depends on both potential energy and the kinetic energy. All right, so I'm sure you're okay with this, the differences between the two. All right. So, having looked at the definition of temperature, its SI units, and the differences between heat and temperature, it is appropriate for you to answer some questions based on what we have just discussed. All right. So, in your own time, answer these 6 questions. The first one, we are saying define the term heat and the temperature. When we were looking at the differences between heat and temperature, we said that we can use definitions to distinguish heat from temperature. Right, you may not have to copy the definition it's given. You can try to define these concepts in your own way, the way you understand, without, of course, changing the meanings of the concepts. So define the terms heat and temperature. All right. In a manual paper, in an exam, where you are asked to define a term, all right, a term, the definition of a term is simply worth 1 mark. All right, so you define the term heat as energy that flows from the region of high temperature to the region of low temperature. That is 1 mark. All right, no matter how long a definition appears to be, the mark allocated to a definition in physics is 1 mark. All right, you also define temperature as the degree of coldness or hotness of a substance. Again, that is worth a mark. So you cannot have a definition that has or allocated that is allocated more than 1 mark. All right. All right. So define heat and the temperature in your own wording. It may not be a direct copying from the definitions that we have looked at before. All right. Number 2, explain any 5 differences between heat and the temperature. You can go an extra mile by looking up from the internet and other sources more differences apart from the ones that we have looked at. There are more differences between heat and the temperature. All right, between heat and the temperature. Use the kinetic theory of matter to explain why heat always flows from the region of low or high temperature to the region of low temperature. Remember what the kinetic theory of matter states from your Form 3 physics. It states that matter is made up of tiny particles, all right, which are in constant motion. But then we are looking at what happens. One side, one end, you have high temperature there. All right, the other end, you have low temperature there. The behavior of the particles can be used to explain why heat always flows from the region which is at high temperature to the region which is at low temperature. So can you apply the kinetic theory to solve this particular problem? All right. Next, you convert 16 kelvins to degrees Celsius. We also saw how you can convert Kelvin to degrees Celsius or the other way around. It was Celsius to Kelvin. All right, using the formula that we looked at before. Explain the main differences between the Kelvin scale and the Celsius scale. This we have not tackled in this lesson, but it is assumed that you looked at the differences between these 2 temperature scales in Form 3. Lastly, you state the SI unit of temperature. Kindly forward your solutions to the number that is shown here, and I'll be glad to give you feedback on the same. Okay, so please find time to work on these questions and forward your work to me to mark. But remember to like the channel, to subscribe, to like the channel, and hit the notification bell so that every time a video is uploaded, you don't have to miss on the lessons. All right, so let's now look at thermal expansion in solids. Remember, that one of the objectives of the topic is to explain the thermal expansion of solids, liquids, and the gases. So we are going to go in that order, starting off with the explanation on expansion in solids. Okay, recall from your Form 3 physics on kinetic theory of matter, one of the properties or some properties of solids is that particles are tightly packed together in solids and that they do not flow. Instead, they simply vibrate about fixed positions. Particles vibrate about fixed positions. And so what happens to the particles when they are heated? All right. Okay, so that's basically what we are going to dwell on, and then we provide a physics explanation as to what causes expansion really in solids. And then later we are going to look at thermal expansion in liquids and then in gases. All right, but it will be reasonable for us to, before we proceed to define thermal expansion, what do we mean when we are saying thermal expansion? When we say thermal expansion, really what is it? All right. Thermal expansion in physics, thermal, first of all, the word thermal means heat. Okay, heat energy. So heat energy is involved. Any situation which involves heating, then there is a thermal activity there taking place. Thermal is referring to heat. All right, that's why we say thermometer. Thermometer. Of course, the thermal is heat, but a thermometer does not measure the amount of heat. Rather, it measures the temperature of it. Okay, of the substance. So we are saying thermal comes from heat, and expansion, it comes from a verb to expand. So thermal expansion, what does it mean? Thermal expansion is defined in physics as an increase in length. All right, an increase in length. So an object becomes longer than it was before heating, and also an increase in volume. Remember that volume is the amount of space that an object occupies. All right, so in this case, volume increases, length increases, volume increases, as well as area. Area simply refers to the measure of surface. Measure of surface increases, length increases, volume increases. All right, when an object is subjected to heat energy. So what we are saying is that when a body is heated, its length, volume, and area increase in magnitude. The magnitude of length, the volume, and the area increase due to the heating. So that change is called thermal expansion. Right, so you may be asked to define thermal expansion. What is the thermal expansion? Thermal expansion. So thermal expansion is simply an increase in length, right, volume, and area of an object when it is heated. Okay. The opposite of thermal expansion is what is called thermal contraction. Thermal contraction. Definition, we define thermal contraction as a decrease. It's the opposite. We are saying expansion is increase. Contraction is decrease. All right, so these quantities, length, volume, and area of an object decrease or decreases when the object is cooled. Let's say that the object was at 45 degrees Celsius, or okay, and then it is cooled. It is moved from the source of heat and allowed to cool. All right, so as it is cooling, its size is going to decrease. The quantities that decrease as the body is being cooled are length, volume, volume, and the area. Unlike when the body is being heated. When it's being heated, the quantities that change are length, volume, and area. An examiner can ask you to state any two physical quantities that change when an object is heated. So the quantities that change are the length, volume, and the area of that particular body. I hope we are moving together. In Form 2, you learned that thermal expansion can be demonstrated experimentally by using a ball and ring apparatus. A ball and ring apparatus. All right? Okay, so you are familiar with a ring. You are familiar with a ring. Okay. And then you have a ball. You have a ball. You have a ball, and which is allowed to enter, depending on okay, it is allowed to enter this. This is an opening usually. This is an opening. All right, so this is a ball. This is a ball. You encountered this in Form 2, in the same topic, thermal expansion. And then you have a ring. All right. So you do recall that before the ball is heated, and allowed to pass through the hole, the ball could easily pass through it very easily. Okay, it could pass through it very easily. But when the ball is heated, because due to expansion, it is going to become larger, too large to fit into the hole, or to enter through the hole. So when heated, the ball expands or increases in length, volume, and the area, such that when it is allowed to enter here, when it's brought to the hole here, such that it enters, it will not be able to enter the other side. Get to the other side because the ball becomes larger. It's enlarged when it is heated. Again, when it is cooled, when the ball is cooled, it shrinks. It decreases in length. Its length, volume, and the area decrease, and it is smaller enough to get through the hole here, through the ring. So this is called the ball and the ring apparatus. All right. So you can also just go through your notes, the Form 2 notes, just to remind yourself on how a gauge apparatus, bar and gauge apparatus, can be used to show the phenomena of expansion. Very important. So in this topic, we are going to go on. We are not going to use the ball and the ring apparatus or the bar and the gauge apparatus anymore, but we are going to use what is called the cast iron bar breaker. So instead of using the ball and ring apparatus, we are going to use another instrument which is called the cast iron bar breaker to demonstrate the phenomenon of thermal expansion of solids. Great. I hope we are together there. So let us look at an experiment that could be carried out to demonstrate thermal expansion in solids using a special instrument known as the cast iron bar breaker. All right. So you can have a question like this one in paper 2 of your Msce physics. okay, where the question simply says describe an experiment to demonstrate thermal expansion in solids using a cast iron bar breaker. So here we have specified what you need to use, what it needs to be used. We are not saying you should use the ball and ring experiment or the bar and gauge apparatus, but you should use, in your explanation, you should use the cast iron bar breaker. So this particular question is specific. He's asking us to describe that experiment using a cast iron bar breaker. So the presentation we are going to have here on the description of the experiment is as Maneb recommends, the format that is recommended by Maneb. Okay, so we're going to go through the description as Maneb recommends in terms of the format. How an answer to a question that says describe an experiment, how is it supposed to be presented? All right. Okay, so remember once again to like the video, to hit the notification bell, and subscribe to the channel so that you don't miss any future videos. All right, so first you have to state materials that need to be used, that will be used. So in this experiment, we are already told that we need to use the cast iron bar breaker, not the ring and ball apparatus or bar and gauge apparatus, we are told. So in the materials, we specify, we mention that we shall need a cast iron bar breaker, 2 Bunsen burners, and a thin iron rod. Now, in descriptive questions like this, when you have mentioned all the materials that are needed for a particular experiment, correct materials, usually you get 2 marks. Okay, but where you have more materials than, let's say you have a particular question requires that you should mention, say, 4 or 5 materials, and you happen to mention 3 correct materials, it means you get 2 marks still. But when you mention any 2 materials correctly and you miss others, you get 1 mark. And you don't get a mark when you mention only 1 material correct. Okay, so that's just an exam tip which you need to be aware of. So we are saying mention all the materials. But sometimes you can skip mentioning the materials. You just go straight to the procedure. You simply go to the procedure and mention those materials that will be required, that will be needed. As you are describing the procedure, you mention the materials within the procedure. You still get marks for mentioning those correct materials. All right. That's very, very important. So fix the steel bar on the frame by inserting the thin cast iron rod in the hole on the steel bar as shown. So this is the setup. This is the setup. Depending on the nature of the question, you may not have to draw this one, but drawing it will give you a competitive edge in terms of marks. So it may give you more marks. You may earn yourself marks by drawing this. Anyway, let's just look at what this is. So this setup is called cast iron bar breaker. This is a steel bar, There's a steel bar here, which is basically metal. So this whole setup is called cast iron bar breaker. It is made up of a steel bar, as you can see, which is placed between two frames. On one end there is a nut just to securely fasten this, to put this in place so that it does not shake. All right, so you tighten the nut there, okay, and the other end has a hole through which cast iron is inserted. So fix the steel bar on the frame. So this is a frame. All this you see here is a frame. So we're fixing the steel bar, and then insert the thin iron rod into the hole here. Okay, it's a bit tricky for you to see this. What it is like, you have something like this. So this is the steel bar, all right, and then it has a hole, one end, this part here, it has a hole. So it is through this hole that you insert what? Thin cast iron rod. So the thin cast iron rod is inserted there like that. That's what is happening here. So you have it inserted like that, and then it goes the other end. Right, that's very, very important to note. So the thin rod is the one that needs to be broken due to the expansion of the steel bar. All right. Secondly, we have two Bunsen burners. So the steel bar is heated by the two burners. You have burner one there, you have another burner there. It is important to use it or to heat the steel bar using two burners in order to make sure that the heat is uniformly distributed, or put simply, to ensure that the whole steel bar is heated. Because if you heat the steel bar using one Bunsen burner, it means only one region or part of the steel will be heated and the other one will not be heated. Therefore, the expansion of the steel bar will not be uniform. So to ensure uniform expansion, they may ask you, why is it advisable to use two Bunsen burners? It's in order to ensure that there is a uniform distribution of heat and therefore uniform expansion. So before we move on to the next slide, we are saying that the thin iron cast iron rod is the one to be broken. It's the one to be broken due to expansion. So this is fitted there, all right, such that when this steel bar is heated, expectedly it is going to expand. So as it is expanding, the whole of it will expand. This rod will be pushed against the frames. Seemingly, this, as it is expanding, it will appear as if this steel bar is moving, but it's not moving, it's simply expanding. So the expansion will cause the thin cast iron bar to be pushed against the frames, the outer frames, and eventually that is going to cause it to break. All right. Similarly, if we have this heated in the first place before we insert the cast iron rod, what is going to happen as it is cooling, when we insert this and allow it to cool, it is also going to be pushed against the frames, and it will lead to its breakage. That's very important. So let's look at the explanation of what is going on. Right, so clamp the steel bar strongly and observe what happens to the cast iron rod. Right, so you clamp the steel bar. I mentioned that the steel bar needs to be tightly clamped and using the nut so that it does not shake on its own as it is being heated. It has to be tight. It has to be tight. All right, so you observe what happens to the iron, to the cast iron rod. So as long as it is not heated yet, no significant observation can be made in terms of in terms of its being broken. Then heat the steel bar strongly using 2 Bunsen burners and observe what happens to the cast iron rod. All right, so I mentioned earlier on that that when you heat, when this part is heated, this steel bar is going to expand. That expansion will cause the what? The cast iron rod to be pushed against the frames, so that it is going to break. It is going to break. Please take note of that. So heat the steel bar strongly using 2 Bunsen burners. 2 Bunsen burners are used to ensure uniform distribution of heat and therefore uniform expansion of the steel bar. So you observe what happens to the cast iron rod. All right. Repeat the experiment this time by heating the steel bar strongly and inserting the cast iron through the hole. Then clamp the rod firmly. Right, so in the first case, you start by heating the steel bar and then observe what happens to the cast iron. In this repetition, you are doing the opposite. So you start by heating the steel bar and then insert the cast iron through the hole. Then clamp the rod firmly. So in this second case, it means you have to observe. You observe what is going to happen to the cast iron rod as the steel bar is being cooled. Right. So it will be observed that when the steel bar is heated strongly, the cast iron breaks with a loud sound. So the observation that will be made in the first case, when the steel bar is heated strongly, it is going to expand. So the expansion will cause the iron rod, the cast iron rod, to break. Why it breaks is because the expansion of the steel bar is going to force the cast iron rod against the frames. All right, and then the result is it is going to break. It is going to break. Right. So when the steel bar is cooled, the cast iron breaks as well. It breaks as well. So the explanation is that on heating, the steel bar expands, pushing the cast iron against the outer frame of the bar breaker. Hence, the rod breaks. So there is a force caused by the expansion there. So that force will push the cast iron against the frames, and therefore it breaks. So on cooling again, the steel bar contracts and pulls the cast iron against the inner frames. This also leads to breaking. So the experiment in short is showing us that solids expand when heated. Solids expand when heated and they contract when cooled. Our observation was on what is going on when the steel bar is heated. It is made to expand. That expansion pushes the cast iron against the frame so that it breaks. So this is what you do present in a question that requires you to describe an experiment that could be done to show that solids expand when heated using the cast iron bar breaker, using the steel bar, the cast iron bar breaker. Very important. Right. Now, having gone this far, I would like you to use the description of the experiment to answer these questions in form of exercise. And remember that once you complete the exercise, you forward the answers to me to check, literally to mark, all right, and then give you feedback. But remember to like and subscribe to the channel, and not forgetting to hit the notification bell so that you are notified every time there is a video uploaded on this platform. All right, so define, using what you have learned, define the term thermal expansion. Define the term thermal expansion. Three things change when an object is heated. So you define thermal expansion in terms of the changes of those three quantities, physical quantities. Name any two physical quantities that change in an object. We mentioned in the course of the lesson that three quantities change when a body is being heated. Can you mention those three quantities? But here the question is simply asking for two, any two. All right, describe an experiment that can be done to demonstrate the thermal expansion of solids using the cast iron bar breaker. So in this lesson, we've looked at such a description. Can you also present it so that I look at it? All right, you'll be required in an exam to answer a question like this. So make sure you are able to present logically in order to maximize your marks, to gain all the 10 marks that are assigned to such questions. All right, lastly, why are two Bunsen burners used instead of one when demonstrating thermal expansion of solids using cast iron bar breakers? We also mentioned this in the lesson today, why two Bunsen burners are preferred to just one. All right, having reached this point, this marks the end of lesson 1. Thank you for your attention. I look forward to meeting you again in lesson number 2 of the topic thermal expansion. So in lesson 2, we are going to look at the thermal expansion of liquids. But before that, we must have a look at the molecular behavior, the particle behavior in solids as they are being heated and they are being expanded. So we'll look at that, and then we proceed to thermal expansion of liquids and then gases. So thank you very much once again. Hoping to meet you again in our lesson number 2. Thank you very much. Take care of yourself.